Hello and welcome! If you're running anything on AWS, you know how absolutely critical network security is. Today, we're going to go way beyond the basics and really architect a multi-layered defense. We are going to build a virtual fortress in the cloud, piece by piece.
So that's the big question, right? How do you actually build an impenetrable fortress in the cloud? It's definitely not about putting up one single giant wall. No, it's about creating smart, layered defenses, and today, that's exactly what we're going to do. We'll architect this fortress together.
So here's our game plan. We'll kick things off with the first layers of defense, that's NACLs and security groups. Then we'll figure out how to connect services privately without ever touching the public internet. And finally, we'll put all these tools together into some really powerful, secure design blueprints.
Every great fortress has to start with a moat. And in AWS, our moat is the network ACL, or as you'll hear it, a NACL. This is our very first and our broadest line of defense. And network ACL basically works at the subnet level, kind of like a guard posted at the only bridge crossing that moat. It checks everything coming in and going out of an entire group of your resources. Now, the key thing to remember about NACLs, and this is super important, is that they are stateless. This means they have no memory. If you create a rule to allow inbound traffic on a port, you have to create a completely separate outbound rule to allow the response traffic to get back out.
Okay, so even if traffic makes it across the moat, it's not home free, not even close. Every single important asset inside our fortress needs its own dedicated protection. And that brings us to our next layer, the instance bodyguard, better known as the security group. A security group is a firewall that's essentially attached directly to your EC2 instance. It's way more specific than a NACL. But here's the most crucial difference. Security groups are stateful. They remember things. They track connections. So if you allow inbound traffic from a source, the return traffic is automatically allowed out. This makes managing your rules so much simpler.
So let's put them side by side, because this is where it really clicks. For scope, security groups are tight, right on the instance. NACLs are broad, covering the whole subnet. For state, security groups are stateful. They have a memory. NACLs are stateless, total amnesia. And for rules, this is a big one. Security groups only support allow rules. NACLs, on the other hand, support both allow and deny rules, which are checked in order. That makes an NACL incredibly useful for explicitly blocking traffic from, say, a known bad IP address you never want to hear from again.
Now, the real power here isn't in choosing one or the other. It's about using them together. A classic and incredibly effective pattern for pretty much any multi-tier application is creating what's called a chain of trust using security groups.
This slide just shows that pattern beautifully. Your web layer security group, it's fine taking traffic from the internet. But the application layer security group, it doesn't trust the internet at all. It only trusts traffic that comes from the web layer security group. And then you have the database layer, which is even more paranoid. It only trusts traffic from the application layer security group. By referencing the groups themselves instead of a bunch of IP addresses, you create this dynamic, super secure, least privileged design. It's really elegant. Okay, our fortress is now pretty secure internally. But what happens when we need to connect to other services? Maybe they're in other VPCs or other accounts or even AWS's own services. We can't do that by exposing everything to the public internet. We need secure corridors.
Here's a situation you've probably run into. You've built a critical internal API. Now multiple teams, each in their own separate AWS accounts and VPCs, need to use it. How do you give them access securely without ever routing that sensitive traffic over the public internet?
The answer is AWS PrivateLink. This is the technology that lets you establish that secure private connectivity directly from a consumer VPC to a specific service in a provider VPC. It's a game changer. So here's how it works. The provider, that's the team with the API, creates an endpoint service. The consumer, the team that needs to use it, then creates something called an interface endpoint right inside their own VPC. That endpoint gets a private IP address from their own subnet. And just like that, all the traffic flows entirely over the AWS backbone. It never, ever touches the public internet. This exact same idea applies when your private instances need to access native AWS services. How can an EC2 instance that's sitting in a private subnet talk to S3 or DynamoDB if it doesn't have an internet connection? This is where VPC endpoints come in. For most AWS services, you're going to use an interface endpoint. It works using PrivateLink and basically gives the service a private IP right in your VPC. But for S3 and DynamoDB specifically, you can use a gateway endpoint.
This is a little different. It just adds a secure route to your VPC's route table, which directs traffic for those services over the AWS network instead of the internet. Okay, so now we got all the individual tools. We have our NACLs, our security groups, our VPC endpoints. Let's see how we can put these together into some really powerful architectural blueprints for success.
Let's dive into 4 really practical design patterns.
First, you've got the centralized security VPC, which makes life easier by routing all traffic through a single inspection point. Next, the shared services hub, which is all about reusability. You host your common internal services and share them out with PrivateLink. Third, the isolated consumer model. This is perfect for SaaS providers who need to give customers secure, private access to their service. And finally, the hybrid cloud gateway, which is how you build that secure, scalable bridge between your on-prem data centers and AWS.
And this really brings us full circle. The key thing to take away from all this is that the best cloud security isn't some single high wall. It's all about having a series of intelligent, layered defenses. You combine NACLs as your moat, security groups as your bodyguards, and PrivateLink as your secure corridors. And that's how you create a truly robust defense in-depth strategy.
So, your network is secure. It's built on proven patterns. But building the fortress is really only half the battle. The next critical question you have to ask is, how do you operate it? How are you going to monitor all that traffic, centralize your logging, and automate your response when things go wrong? That, right there, is your next operational challenge. That's the next frontier.